Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellen, Illinois. This video today is going to look at Advent of Code 2020 Day 14 festivities in my new favorite language, Python. This language is so much fun. These programs have been so much fun to write. You can get so much done so quickly. It's just so cool. So for this part one, you have a computer program that you're kind of working your way through. You have a mask that you should read this yourself, of course. I'm just going to give you the dime tour here. I have a 36-bit mask, and I'm trying to use this mask to change data values, and that's what I believe is going on because it's version 1 of my software, at least version 1 of my hypothesis of how the compatibility of this computer system works. And so what I'm going to do is, first off, I got to be able to make sure I can extract the data I need based on what's going on. So if this line of code comes in as a mask, I'm basically just going to take whatever's on this right-hand side and bring it in. And that's what I'm doing here for these two lines of code here. If I can, so I'm saying this is for later. I said I'm going to have a 36-bit size in memory because I'm going to convert an integer value into a 36-bit binary value, and I'm going to set up a dictionary because I can't set up a list, because if I set up a list with 36-bit addressing, the addressing will go way beyond 32-bit addressing, and let's say we won't have enough memory to run this program, and it'll just take forever. Maybe it would take forever, maybe it won't, but anyway. So anyway, coming back down to it, if I split an individual line in my file up and I say, hey, what's on the left side of this equals? If there happens to be a mask, the word mask, then I know I can go ahead and split by the equals and then take whatever's on there and then put it in, and that's my mask. That's what this will come in as. So this is just a fancy way of doing that. And basically I made sure that I went through this and I said there's only two types of things. There's no error codes or anything in here. If it's not a mask, then it's got to be memory. And so all of this crazy code is a way of converting if this is a line of code here, converting this number. Address is easy. I don't have to do anything. Well, easy is easy is a misnomer here. I need to extract this number, the 36932, from it, and this is what it'll do is say, okay, split this thing by mem, then split it with the opening square bracket, and then split it by the closing bracket and get me the 0th element and store that as an integer, and that'll get me the 36,932. And so the next line basically does the same thing for the value over here. But the thing is, at least to get started here, I need to convert this thing into binary. An integer value comes in, 186083, and I need to split it up and turn it into a binary digit. So it comes in as a string, and I do all this work, blah, 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 get me the second, get me whatever, split this, and get me the first element, which is the right-hand side, and then take that, convert it from a string to an int, and from the int is base 10, if you want to think of it that way, even though it's in binary and IEEE 754 format, or maybe not for an integer anyway. But anyway, so 32-bit format, and then turn it into pure binary, and then turn that into a string. And then this is easy, simple stuff. And then for whatever reason, it puts a 0B on the front of that string, and I just wanted to get rid of it. So I say, okay, get me elements 2 and beyond. And so then what I do is this thing needs some 0 front loaders, because I need to make this 36 bits in length, and I don't know, offhand how many bits this thing is going to be, but I do know if I call for length of it, and then I can say, okay, add front pad 36 minus that length number of zeros, and then throw the value on top of it. So you'll always get a 36-bit value as a string. And then this is where the magic starts to happen here, is now I go ahead and say, because of the rules of part 1 of this problem, I say, okay, for every I in range, so for every bit go through here, and say, I'm rewriting the memory address as a string, so I say, okay, if the memory address, if the value at that I location in the value, as we're going through each bit, if it's an X, then it goes in as the value, whatever that is at that case. Otherwise, it goes in as whatever the mask is, if it's a 0 or a 1 or whatever, or you get the point there. So and that's all there is to it. If it's not, if it is an x, then it becomes, I guess if it's an x, it's whatever the value previously was in there. Otherwise, it's replaced by the mask. So like if it's a 0 or a 1. So basically some of the bits are maintained, and some of the bits are transferred by the mask. And if you do this, you just run this code over and over and over again. And then you go ahead through this and you say, at the end of the day, go through my dictionary for every value I have in my memory, or in my memory dictionary. Get me an address. Get the address, and I guess get me the value if you want to think. Maybe I wrote the wrong word here, but that's okay. It's 1:50, almost 1 in the morning. Get the address, converted, from a binary string into an integer, and then sum it up. And if I run this correctly, there I go. It's a huge, 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 huge number. And here I go. And then this matches up with what I'm expecting. 1748, blah, 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 893. So I feel this feels magical, but yet this feels absolutely insane when it comes to something like this of what the hell am I trying to do? But at the end of the day, it gets the job done. I would add some comments if I was doing this professionally. I'd probably I'd probably be more comments than code with this stuff when it comes to parsing the data. But that's part 1. So let's take a look at part 2 as well here. Part 2, as you could imagine, is just a little bit more involved. And this time around, oh my goodness, the fun of this one, that we're going through the file, we're opening the file, we're splitting by new line, we're still using 36-bit addressing, we're still using a dictionary, we're still setting up the mask every time we see it, but now everything changes when we hit this memory. When we want something like this, this completely changes everything. And instead of changing values, instead of changing values at memory addresses, we're actually going at one memory address, we're going to be changing values at many addresses, which is just, instead of masking the data value, we're going to be masking the address against the mask. And oh my goodness, right? For every x, we're going to be doubling the number of elements that need to be changed by this line of code. So for this how many x's? 1, 2, 3, 4, 5, 6, 7, 8, 9. Forgive me if I didn't do it right, but let's just say there's 9 of them here. 2 to the 9th power. 512 different memory locations are going to be modified by this one line of code alone. So there's a lot of work going on here. And so looking back at this part 2, what am I actually doing here? So this is a 3-step process here. And so I basically I did the exact same stuff here, but this time I made address and value both binary, a binary string, so I could do whatever I need to do. So I broke this into 3 steps for each line of code. And the first step here is to convert the convert the number of the memory address, convert this 36932 into something we can actually use. And so what I did here is I just go, okay, if it's a 1, make it a 1. I'm just following the rules here. Oops, these rules right here. And so I'm just saying, oops, sorry about that. And so what I'm doing here is saying, okay, if every bit inside of this thing, as I've converted it into 32 bits, if it's a 1, leave it alone, because if the bit mask is a 1, then put a 1 in there. If it's a 0, leave it unchanged. That's this part here, whatever was previously in the address. If it's a 1, put a 1 in there. Otherwise, leave the x in. That's for right now. That's just to convert, because that's kind of what they're doing here. When it talks about this, step 1 is just to convert from address to result, and I call that masked value instead of result. So that's where you get to right here. This is the end of step 1. This is how you would do step 2. And so now this is where things get a little complicated, because I'm going to need a list of data. And as I'm going ahead and I see an x, I'm going to have to double that data and then add a new digit on top of it. And so that's what I'm doing here. The number of the actual number of of values I'm going to have to change. The floaters, I start with an empty list, because again, these are all strings. These aren't lists of lists. These are lists of strings. And for every digit in the masked value that we've calculated, all 36 bits, if it isn't an x, then you just go ahead and Just for every element that's currently in there, just throw that digit on top of it. So like if it's a 0, put a 0 at the front of everything. If there's one element in here, there's 10, or there won't be 10. If there's 1, if there's 8 or 16, just put that digit in there. But if it is an X, this is, where things have to get more complicated. And I don't know a better way to do this at 1 o'clock in the morning. But what you do is you just say, okay, let's create a new list. And for every item in the old list, let's duplicate it. And then for half of them, put a 0 in at the end. And half of them, put a 1 in at the end. Excuse me, because that's what we're doing. You can see that here. Like anytime you see an X, half of the time you're going to see a 0, and half the time you're going to see a 1. And so every time you split these, this 0, this will double, and then you'll get a 1. And so you can see here. You can see, maybe you can see here. This is 0, 0, 0, 1, 1, 0, 1, 1. And that's for the first element that needs to do this. But for something that has 3 X's, you can see 0, 0, 0. This is, if you want to think of those 3 bits, it's 1, 0, 1, 2, 3, 4, 5, 6, 7 in 3-bit binary, but it's the same idea that if I see an X, I double my my list of the things that need to be modified, and then half of them get a 0 and half of them get a 1, and we just move on and move on and move on. And then at the end of the day, for every element in this list of data, that's the memory address that needs to be set to whatever the current value is. So like it's saying, like, look at this, or like for this case here. Shoot, where is it here? Up here? Where's the program? For this guy, 42 equals 100. These 4 memory locations get 100 at the end of the day. And for this one, we said mask 26 equals 1. At the end of the day, all of these 8 memory addresses get the 1. And that's basically all there is to it. And then you go through the entire list, or the entire dictionary at this point, like you did before, and you go just sum up, go through all the memory values like you did before, and say, hey, what is the sum of all these things? And if I run this and I get lucky, there I go. I get 416, blah, 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 and there's my answer right there. So you can see that my code is working. The last couple days, a couple of you guys have been saying that my code doesn't work for your example sets, your test data. I hate seeing that, but I can only work with the data sets I have, right? I mean, so if I had more data sets, I could, make this more robust. But all I can say for today is this works for me, and I'm happy with the result, and I'm ready to go to bed and have a nice tomorrow. And I hope you do too. Hope you have a it's finals week here at the College of DuPage. Stressful time for everyone. So I hope everyone has a peaceful, restful, as stressless as possible week. And everybody gets the grades that they earned, and everybody gets the grades that they want. So as always, swardb@cod.edu is a great way to get a hold of me. Better way to get a hold of me lately is comments here on YouTube. I've been spending a little more time responding to people. It just, with finals week coming up here, I don't know how much time I'll have even for this. I might have to this might be my last day. We'll see. You never know what the problem is going to be tomorrow. Things are getting more difficult. Yesterday's was my goodness, was a pain in the butt trying to figure out at least common multiples and stuff like that. But I digress. I'm going to stop talking. I really don't like talking for as much as I'm a professor. I'm that shy introvert. Maybe you can tell from my voice. But anyway, thanks again for sticking with this video with me. Have a great day, and we'll see you next time.